These are the Algebra 2 notes. Today we're going to be covering systems of equations story problems. So the first thing you need to do is just read the equation, read the story problem. A group of 42 people go to an amusement park. The admission fee for adults is $16. So adults, 16. Admission fee for children is 12. And the group spent $568 to get into the park. They want you to write a system of equations, which means two equations that can be used to represent the situation. So the first equation I'm going to have is going to be the price of everything. So I'll have $16 for the adult plus $12 for the child. And that was a total of $568. We always put the total after the equal sign. And then the only other number I have here is a group of 42 people. So the second equation is just going to be the amount of people. I don't know how many adults or children went, so I'm just going to put A plus C, and then I know the total is 42. And that's my system of equations. The next thing I'm going to do, I'm going to solve this one using elimination because I have all the A's, C's, and numbers lined up. So I'm going to multiply this one by negative 16, so that way it cancels out the A's. And I'm just going to distribute. The top one stays the same. The bottom one gets multiplied by 16 negative. And then I'm going to eliminate the A's. Positive 16 and negative 16 cancel. Combine what's left. And divide to solve for the amount of adults. 26, and again, that represents the adults, the amount of adults that went. And now I'll just need to plug that in to my equation. And you get to choose which equation you plug it into. So I think this one's pretty easy. There are fewer numbers. So I'll plug in my 26 for A. And then solve by subtracting. $16 children. So it says so we'd have 26 adults and 16 children. For the next problem, this is talking about tickets to a softball game. Again, we have $4 for students, $7 for adults, $795 was made, and then you have the total amount of people again. So we'll set this one up a similar way to what we did before. $4 for a student plus $7 for the adult. So this is all the money, all the prices go here, and $795 total. And then for the next one, the students plus the adults was equal to 165 people. So you're kind of putting these into two categories. I'm going to attempt to cancel out the S's. So I'll multiply the bottom one by negative 4. The top equation I'll leave exactly the same. The bottom equation gets multiplied by negative 4 through the entire equation. Eliminate the S's and combine what's left. Divide by 3. A equals 45, and again, that's the number of adults. Once you found one answer, you can plug it in to any of the equations that you choose. Again, I think this one looks the easiest. Fewest amount of numbers. So S plus 45 equals 165. And subtract 45 to get 120 students. And let's just make sure we answer the question. How many students were at the game? Got it. How many adults were at the game? Got it. All right. On the back side, you have two more different types of problems. These are done a little bit differently. The categories are going to be different. So Castell and Gabriella are selling pies for a school fundraiser. Customers can buy apple pies and lemon meringue pies. Castell sold 6 apple pies and 4 lemon meringue for a total of $80. Gabriella sold 6 apple pies and 5 lemon meringue pies for a total of $94. What's the cost of each pie? So on the front side, we are putting all the money into one category. That had to do with the prices. This time, we're going to base it more on the person. So we're going to put all of Castell's numbers in the same equation. So 6 apple pies. Let's do apple for A. And 4 lemon meringue. I'm going to call that meringue. M equals 80. So those are all Castell's numbers. I'm going to do the same thing for Gabriella's. 6 apple plus 5 lemon meringue equals $94. The A's are already the same number, so I just need them to be opposite signs. I'll multiply the bottom one by -1. Keep the first equation the same. Change all the ones in the second equation to negatives. Cancel out. -1m equals -14. Divide by -1. And we'll get our lemon meringue pies at 14. And we are looking for the cost, so that's actually going to be $14. I'm going to plug in m equals 14 now. As I look at both of these equations, neither of them looks particularly easy to plug into, so I'm just going to use the top number. 6a plus 4, and I'll plug in my 14 for m, equals 80. And just carefully multiply. Subtract. And at the end, divide. So it looks like the apple pies are only $4 and the lemon meringue pies are $14. Example number 4 is set up very similar. So see if you can set up this problem. You're going to set up these according to the first day and then according to the second day. So all the first day information goes in one, all the second day information goes in another. 3 senior citizen tickets on the first day, 3 child tickets, and a total price. That's all going to go in the first equation. I'm going to call it senior citizen for S. 3 child, $69. Then we're going to get all the information from the second day. $91. That's got to go after the equal sign. That's a total. 5 senior citizen, 5S. 3 child ticket, 3C. Once I've set it up, I notice that the C's are the same exact number, but not the opposite signs. I can pretty easily multiply one of these by -1 and get it to cancel out. Keep the top one the same, Or you can multiply the top one by a -1. That would work as well. Either way, the C's will cancel. And you'll be able to solve the equation, even if your numbers are not the same as mine. And divide to solve. Regardless of how you solved, you should get an answer of 11. That's going to represent our senior citizens. And it says, what is the price? So that's going to be a dollar amount, $11 for a senior citizen. And then we'll need to plug in S equals 11 so we can find our answer for the child. The top numbers in the top equation look a little smaller. I'll go ahead and plug in there. So 3 times 11 plus 3C equals 69. Multiply. Subtract. And divide. So it's $12 for a children's ticket and $11 for a senior citizen's ticket.